Hi, I'm Alan Hawse. Welcome back to Cypress Academy Wicked Wi-Fi 101. In this video, I'm specifically going to talk about the man-in-the-middle attack and how you prevent it. The man-in-the-middle attack I'm talking about is the internet security attack where you think you are talking to a specific server, but really a bad actor is intercepting the message, de-encrypting it, and then relaying it on. This puts him in the position of being able to decode traffic to and from the server. Let me show you. If your client attempts to make a connection to a server that I'll call real server, but an evil server called MIM gets in the middle, the first thing that happens is the MIM will send you its public key, then will open up a connection to the real server. You will get the public key of the MIM and you will send it a symmetric key encrypted with its public key. The real server will then send its public key to the MIM. Then the MIM will send a symmetric key back to the real server. Now you, the poor unsuspecting client, think you're connected to the real server, but actually you're really connected to the MIM. And the real server thinks it's connected to you, but really is also connected to the MIM. Then you go on your merry way. You encrypt your traffic and you send it to the MIM. The MIM decrypts it because it has your key. Then it re-encrypts it and sends it back onto the real server. This can actually happen in the real world fairly easily, as you don't have control over any of the routers between you and the server. The most likely place this bad actor can attack you is with a compromised Wi-Fi access point, say in an airport or something, but it really could be anywhere. Now that you know how this happens, how do you prevent it? The answer to that question is with certificates. To understand certificates, you need to know two new things. First, a cryptographic hash, and second, a certificate authority. A cryptographic hash is just a fancy checksum, often just called a hash. The fancy part of the cryptographic hash involves a little bit more of that crazy math that I was talking about earlier. Specifically, the algorithm that you follow is essentially a guarantee that any known input will only generate one unique hash, and that any change you make to the input will always generate a different hash. These hashes are sometimes called message digests because they take a big bunch of data and they squish it down into a small amount of unique data. For instance, SHA-256 takes any amount of data you want to put into it and generates a unique 256-bit number. Now that you know what a cryptographic hash is, let me explain a little bit more about the certificate. In order to be sure that the server you are actually talking to is the server you mean to be talking to, you can build the public key of that server into your firmware. Then, when you make a connection, the server can send you a secret message that's encrypted with its private key. You can then decode that message using the server's public key, which you have built into your firmware, and then look at the message. If the message makes sense, then you're sure that it was sent only by that server. But wait, that means you need to have the public keys of all of the servers out there on the internet built into your firmware. That's not very practical. So now what? Well, the solution to that problem is to use a certificate. A certificate is a file that has a public key of the server that you know and trust and the public key of a server that you are talking to. It also includes the DNS name of the server you are talking to, plus a signature. What is the signature that you're talking about? Well, the signature is the public key of the certificate authority and the public key of the server you are talking to hashed together with a cryptographic hash and then encrypted with the private key of the certificate authority. When you open a connection to a server, it sends you its certificate. You then take the public key of its certificate authority and the public key of the server. You hash it, then you decrypt the signature that was sent to you in the certificate using the certificate authority's public key. Then you compare the decrypted signature with the hash you just created. If they're the same, then you know that that signature hash could have only been created using the certificate authority's private key, which can only have been done by the certificate authority. By extension, if you trust the certificate authority, then you trust the server. Basically, you are depending on the fact that a certificate authority would only sign certificates for servers that are real. There's a bunch of other things that can happen inside of certificates. For instance, you can create a chain of trust. In other words, A trusts B and B trusts C. So if you trust A, then by extension, you trust C. Certificates can expire. They can be restricted to a certain domain or a particular host. However, I have given you all of the fundamental properties required to understand, and I recommend that you start by letting WICED take care of the details. You can dig in later. There's tons and tons of videos on the internet and classes and documentation that can help you. I described how a client verifies a server's certificate. This exact method can optionally also be used by a server to verify a client's identity. That gives you a socket that is secured both ways. It's very common for HTTP connections to not verify the client identity, but many other connections, including MQTT, often verify both sides. I think that in the future we will see many more full certificate verification protocols. The last trick of this whole puzzle is that you start a connection using public key cryptography. Then you use one of the many key exchange systems, for example, elliptic curve Diffie-Hellman, to switch your encryption to the more efficient symmetric key encryption. These certificates that I've been talking about are generally in a format called X509. In the next video, I will talk more about how you actually get, create, store, and use X509 certificates in your WICED Wi-Fi project. You can post your comments and questions in our Wi-Fi developer community, or as always, you're welcome to email me at alan_hawse@cypress.com or tweet me at AskIoTExpert. Thank you.